Hello and welcome to Module 2 in our series SDL2 with C++. In today's session, we will be talking about event handling. Now, no discussion on event handling can begin without talking about SDL event. So what is SDL event? Essentially, SDL event is a union of structures. And each of the structures in this union pertain to an event defined in the SDL library. Looking at the internal definition of SDL event, you can see how the type def statement has been used to give the existing data type union a new name. Looking at the members of the union now, the first member type will hold the type of event that has occurred. So to give you an example, when a key on a keyboard is pressed, that's one type of event. When the key is released, it's another type of event. Looking at the second member, active, this member is of SDL active event type, right? It's not an int type or a char type. It's of SDL active event type. SDL active event is essentially a structure defined in the SDL library. Similarly, the next member key is of SDL keyboard event type. An SDL keyboard event again is a separate structure defined in the library. Similarly, button is of SDL mouse button event type. An SDL mouse button event is again a separate structure on its own defined in the SDL library. Now, because SDL event encompasses or has under its umbrella all events defined in the library, it is considered to be the core of event handling in this SDL library. In fact, it is SDL event that allows for managing events in the queue. Now, if you're wondering what the queue is, to put it simply, it's something like this. Events as they occur are pushed onto the queue like so, and then they are pulled from the front of the queue one by one until there are no more events in the queue. But how does this work internally? And that's where the function SDL poll event comes into play. Before we proceed, may I ask that you leave a like on this video, and if you're enjoying the module, subscribe to the channel. This not only goes a long way in promoting the channel, but also keeps me motivated to create more content like this. Thank you. So let's now talk about SDL poll event. Now, SDL poll event is a function that is responsible for pulling or removing an event from the queue. The argument to this function is an SDL event type variable that we declare in our code. Now, some important points to note about the SDL poll event function. One is that SDL poll event requires a pointer to be sent as argument. And so what we do is we send the address of the same SDL event type variable that we declare in our code. The second point to note is that as an event occurs, information about that event is stored in the same SDL event type variable. Note that the SDL event type variable is an empty structure definition, if you will. And so the type of event that has occurred will be stored in the type member of the same structure definition. Talking about return values, SDL poll event will return a 1 when it has pulled an event successfully from the queue. It will return a 0 if there are no more events in the queue. Let's now look at the SDL event definition in a little more detail. On the extreme right, what we have is a description of the data that is returned by each of the members of this union. On the left, we have the names of the members, and on the left of the names, we have the structures that define the types of the different members of this union. So for example, the member key is of SDL keyboard event type. Now, when talking about a key on a keyboard, like I said earlier, the events reported could be either that the key is pressed or the key is released. And so when a key is pressed, the event that is reported is SDL key down. When the key is released, The type of event reported is SDL key up. But where do these definitions come from? For that, we need to take a look at the SDL keyboard event structure definition. Now, looking at this definition, you can see three members there: type, state, and key sim. It is a member type that reports SDL key up or SDL key down. In other words, it reports whether the key has been pressed or the key has been released. The second member, state, returns or reports similar information. It returns SDL pressed or SDL released. Now, because type and state both return similar information, state is more or less redundant. In fact, throughout our series and our project, we will be evaluating the type member of the SDL keyboard event structure. Looking at the third member now, key sim, what does this member report? Key sim reports information on the key that was pressed. Its type is SDL key sim, and you may have figured out that SDL key sim is a structure on its own, and here is the definition of SDL key sim. You can see four members there. The first two are most important to us. Now, the first member, scan code, is the keyboard returned value for the key that is pressed, and therefore it is hardware dependent. The second member, sim, is the library defined value or the SDL defined value for the key that is pressed. If you're curious about the third member, mod, that returns the state of modifier keys, which you may know as being our control key, alt key, shift key, etc. Now let's take another example. If we look at the member button, that is of SDL mouse button event type. Now, when we're talking about a mouse button, either it could be clicked or released. When the mouse button is clicked, the event reported is SDL mouse button down. When the mouse button is released, the event reported is SDL mouse button up. Okay. Now let's look at some sample code. So here we have an SDL event type variable declared, and then using a while loop, we're calling SDL poll event, passing as argument the address of the same SDL event type variable. Using the switch construct, we are evaluating the type member of the same SDL event type variable. Depending on the event that occurs or the event that is reported, we send control to do key down, do key up, or do mouse button up. Now all these functions, that is do key down, do key up, and do mouse button up, are programmer defined. Now to recap, and this is a recap of the first two sessions. Remember that the first step is to initialize all our subsystems, and so we call SDL init. We then call SDL create window to create a window within which our game will run. Remember that SDL create window returns a structure of SDL window type. Once we have that structure, we can then pass it as argument to SDL create renderer, which creates our rendering context. Remember that SDL create renderer returns an SDL renderer type structure, which we can then send as argument to functions like SDL set render draw color, SDL render clear, SDL render present as well. Talking about event handling, remember it is SDL event that is the core of event handling. SDL poll event is what manages events in the queue. When an event occurs, information about the event is placed into the SDL event type variable that we declare in our code, and the type of event that has occurred is placed into the type member of that same SDL event structure definition. Now before we go, let's look at some code. So let me just minimize this. We have our main function. Of course, up there we have our include statements, and then we are declaring our window variable and then our renderer variable. We've done this in the first session, so I won't go through that. We have a bool type variable as well. Coming to the main function now. We call SDL init to initialize the subsystems. We create our window and are rendering context. And then we're calling set render draw color, setting the color for our window. Within this loop now, we're calling check input. So let's go look at that function. And we have within it our SDL event type variable. We're then calling SDL poll event, passing in the address of the same variable. Remember, SDL poll event requires a pointer as argument. Using the switch construct, we are evaluating the type member of this structure definition. And then if a key is pressed, this statement is just going to print the hardware returned value, that is the value returned by the keyboard, and the SDL defined value, just to show you the difference between those values. But we're changing the color as well of the window and then breaking out of the loop. If the key is released, we're again changing color of the window and breaking out of the loop. If SDL quit is triggered, this is what will happen, right? That's all for that function. We then call SDL render clear and SDL render present. I'm sure you know what those do by now. And then cleanup is to clear memory, right? SDL quit to shut down subsystems. Let's now run this. We have our green window. Let me move it so you can see the console. If I press a key, you can see the hardware returned value is 4. That is the keyboard value or the keyboard returned value. And the value returned from the library is 97, which you may know is the ASCII value for the lowercase a, right? Also note that the color of the window changes when I press a key. So I'll press a down arrow key now. Color changes from yellow and then back to orange. You can see the value returned by the keyboard is 81, right? And the SDL library defined value is this big number. Now how this number is arrived at, we will discuss in a later session. I press the up arrow, window changes to yellow and back to orange, and you can see the keyboard returned value and the SDL defined value, right? Now if I keep pressing a key, you see what happens. This prints out so many times, and we'll see how to deal with that again in a later session, right? So I hope all of this is clear to you. If you have any questions, post in the comments. That's all for this session. Till the next session, take care. Bye.